Okay, so what we have learned for last week is the chain rule. So there are two forms of the chain rule. Okay, they're actually all talking about the same thing, but like there are two formats of the chain rule. The first one is you have a function to the power of n. The derivative will be drag the n down, derive the things in the bracket, and reduce the power by 1. So it's 3 components. If the equation is written in the form of y composite gx, okay, it's a composite function, gx put into fx, the derivative will be g dash x and the f dash and gx. Okay, so 2 forms for the chain rule. Okay, so you must remember the thing in the box. It's very, very important. We haven't done example 1 and example 2, so I would like to do example 2 with you and to refresh your memory on the chain rule. So find the gradient of the curve with this equation at the point of 1, 4. So I want to find the gradient at x equals to 1. So before I can find that, I need to find dy dx. Okay, I need to find dy dx. So what is y? Y should equal to, I will say do not put everything on denominator. Try to write into the power form. So it's 16 times 3x squared plus 1 to the power of negative 1. Okay, to the power of negative 1. So this is gx. Okay, this is gx. And then to the power of negative 1. Okay, to the power of negative 1. And the times the 16 in the front. So 16 will still be there. Okay, that's 16 times. Okay, the first thing I will do is drag the power down. So the negative 1. Okay, times the negative 1. The second thing I will do is derive the thing in the bracket, which is gx. I will derive gx. So if I derive gx, that will give me 6x. And the last thing I will do is reduce the power by 1, but not going to change the base. So the base is still that. Minus 1 reduced by 1, you have minus 2. Okay, so what will be that? Negative 96x over 3x squared plus 1 to the power of 2. Negative 96x, derive 3x squared plus 1, then to the power of 2. I want to find the gradient at the point 1, 4. So the y value doesn't really influence the gradient. It's the x value influence the gradient. Okay, the x value influence the gradient. So when x equals to 1, then dy dx will equals to negative 96 times 1 over 3 times 1 is 3, 3 plus 1 squared. So it's negative 96 divided by 16. That will equals to negative 6. So the gradient at that point is negative 6. It's negative 6. So that's how you deal with chain rule. Okay, that's how you deal with chain rule. Okay, example 1 is differentiate y equals to 4x cubed minus 5x minus 2. So again, this is gx to the power of negative 2. So the first thing, I will times the negative 2 in front. And then I will derive the things in the bracket is 12x squared minus 5. The last thing, I will times that, reduce the power by 1. So the power is negative 2, reduced by 1 is negative 3. So what I will have is 10 minus 24x squared over 4x cubed minus 5x, then the whole thing to the power of 3. Okay, that's how you use chain rule. We must remember the chain rule. Okay, we must remember chain rule. Okay, so let's finish up chain rule, and today I'm going to talk about differentiations for other functions except other than polynomials. Okay, it's not polynomials anymore. So we know how to derive polynomials. Something to the power of n, I know how to derive that, but we don't know how to derive other functions. For example, we have learned exponential, we have learned logarithm, we have learned, square root can be x to the power of n, sine, cosine, and tangent. We don't know how to derive all of that. So in this lesson, I will just tell you all the rules about all the other functions, how to derive all the other functions except polynomial. So what functions we really learn? We learn exponential. We learn natural logarithm. Okay, so can you see they're all nature-based? Okay, they're all nature-based. E to the power of x, and natural logarithm will be log ex. Okay, they're all nature-based. If it's not nature-based, I can't do it. Okay, I can't use the rule. And then I have derivatives of circular function. Okay, for circular function, we have another three: sine, cosine, and tangent. Okay, sine, cosine, and tangent. So we have exponential, logarithm, and sine, cosine, tangent. So we need to learn another 5 new rules. Okay, another 5 new rules. Okay, let's have a look at this table. Separate in the middle. Separate in the middle. What do you have? You have fx, f dash x, fx, and f dash x. So let's look at the first column. Okay, first column. Constant. I should cut into half. Okay, read it horizontally. So constant's derivative will be 0. Okay, x to the power of n, doesn't matter what is n, the derivative will be n times x to the power of n minus 1. Okay, so what if you have exponential? Okay, exponential. The interesting thing for exponential, the gradient will still be the same function at itself. Okay, e to the power of x, the derivative will still be e to the power of x. Okay, the derivative will be the same as before. But that's only e to the power of x. How about if I have e to the power of gx? Okay, e to the power of gx. What's e to the power of gx? For example, I have e to the power of 3x plus 1. Okay, that's not x anymore, that's a function. Okay, the power is a function, it's not a single x. So what's the derivative there? Then the derivative will be g dash x times the ex again. Okay, so for e to the power of something, the derivative always contains the component of itself. Okay, and what's the other part? The other part will be the derivative of the power. Okay, so you derive the power and you repeat itself again. Okay, and you times them together. That's the derivative function. So you derive the power, which is gx, that becomes g dash x, and then you repeat whatever you have for e. So e to the power of gx. So it's g dash x times e to the power of gx. Okay, let's look at the next one. Directly look below the logarithm. So logarithm, log ex. Okay, log ex. So what's the derivative for log ex? It's a little bit strange for log because all the other function after derived, they still look similar to itself, or like very similar to, okay, it's similar. For example, x to the power of n, you derive it as n times x to the power of n minus 1. It's still a polynomial, okay, or still x to the power of something. But for logarithm, after you derive it, that will become 1 over x. Okay, your log becomes, what's that? Hyperbola. Okay, your log actually becomes a hyperbola function. I'm not going to show how it worked in that way, but like you need to remember this rule. So log ex after derived, that will become 1 over x. Okay, that becomes 1 over x. But how about if I don't have x in the bracket? I have gx in the bracket. So for example, I have log e 3x squared plus 2. How about if I have log e 3x squared plus 2? So what I will do is I will derive the inside. Okay, I will derive the inside and put that over the original function. Okay, put that over the original function. So for example, this one, the inside is 3x squared plus 2. I will derive that. So it's 6x. And over whatever you put in log. So that is your derivative. Okay, that's the original, that's the derivative. You derive the bracket first and over whatever you have put into log. Okay, so it's g dash x over gx. Okay, we have finished two. Okay, log and exponential. We have finished log and exponential. And let's think about the sine, cosine, and tangent. Sine, cosine, and tangent. The next one is sine. Okay, the sine x will derive to cosine x. Okay, the sine x will derive to cosine x. Okay, sine will become cosine. But how about I have sine gx? Okay, what's sine gx? Let's say we have sine 2x squared plus 2. We have 2x squared plus 2. What that will become to? That will become to g dash x and cosine of gx. Okay, g dash x times cosine of gx. So I'll always need to derive the bracket first. Okay, always need to derive the bracket first. So after you derive the things in the bracket, you have 4x. Times what? 4x will times cosine of gx. So what is gx? Gx is 2x squared plus 2. So the derivative will be 4x times cos 2x squared plus 2. Okay, 2x squared plus 2. And for cosine will be very interesting. Cosine will become negative sine. Okay, cosine will become negative sine. So sine will become positive cos, but cos will become negative sine. Okay, negative sine. So cosine gx. So what's cosine gx? Let's say we have cosine 3x cubed plus 2x. Okay, 3x cubed plus 2x. So you will have a negative sign in front because cosine will become negative sign. Okay, cosine become negative sign. So you have negative. So the bracket is gx. So you want to derive it. So that's 9x squared plus 2. And then cosine will become sine. Sine of gx. So gx is 3x cubed plus 2x. It's 3x cubed plus 2x. So that will become negative bracket 9x squared plus 2 and times sine 3x cubed plus 2x. Okay, so they're all very similar. Okay, you can see they're all very similar. You always derive the things in the bracket and then you maintain whatever you have in the bracket. For sine, you change to cos. For cos, you change to negative sine. Okay, let's have a look at tangent. For tangent, that will become secant squared x. So what is secant squared? So secant x will equals to 1 over cosine x. Okay, it's the reciprocal of cosine. So what is secant? Secant is 1 over cosine. Then what is secant squared x? Secant squared x will equals to secant x and then squared. Okay, you just, for looking at it beautifully, okay, want to look like more better, you not put in the square after, you put the square in the middle of x and the secant. Okay, it's just for like it looks good. Okay, so put the square there, but it actually means that squared. So if it's that squared, that will equals to 1 over cosine squared x. Right? It's 1 over cosine times 1 over cosine is 1 over cosine squared x. But we'll write that secant square. Okay, we'll write that secant square. So tangent will become secant squared x. So the derivative will be derive the inside and change tangent to secant square and then still put the gx in the bracket. Okay, still put the gx in the bracket. So that's the 5 new rules we have learned. So that is the simplest version. But this 5 is the more mature version. Okay, so you can do anything with that version. So this is only, it's only apply, we have e to the power of x. Only apply for sine x. But this it can be sine anything. Okay, sine anything, cosine anything. So I will recommend you to remember all of this. Okay, the right hand side, not the left hand side. If you can remember the right hand side, you can apply that to the left hand side, the easier version. Okay, if you can remember the right hand side, you can deal with the left hand side. Okay, so that's the 5 rules, and again we have, I put this again here. So the composite function, which is you use chain rule, that will give you g dash x times f dash gx. If you have gx to the power of n, you have n times g dash x, gx to the power of n minus 1. And if you times a function by a number, that will be you just derive it and times the constant. And if you plus or minus, you can derive them separately and you add them or subtract them. Okay, so I put everything you need to know for differentiation in this table. Okay, everything you need to learn for differentiation rules in year 12 in this table. So basically you must remember this table. You won't have formulas. I don't think you have formulas on the formula sheet for part 1 exam. So you can't take that. So you need to remember all of that. And in VCAT exam, if you can read through that, the first question is always a differentiation or anti-differentiation question. It's always, okay, it's never changed. It's always a differentiation or anti-differentiation question. So if you don't know the rule, basically lose 2 marks. Okay, for sure, no doubt. That's the first question. Okay, you don't want to make mistake in the first question, so you need to remember all of this. Okay. Example 1. Example 1 says use chain rule to prove some of these rules. Okay, use chain rule to prove some of these rules. Which one I want to prove? Let's think about that. Well, let's prove the log. Okay, let's say y equals to log e bracket gx. Okay, what we know? Okay, we know y equals to log ex. Then dy dx will equals to 1 on x, right? That's the simplest version we have. If you have log ex, the derivative will be 1 on x. That's what we know. So what I can write for this? I can say u equals to gx. Okay, u equals to gx. Then y will equals to log eu. Okay. Okay, the inside will become u become a single variable, and then u will equals to gx. Then y equals to log eu. So what I'm looking for? I'm looking for dy dx. Dy dx, because you put another variable u in, I can say that's dy du times du dx. Okay, I can do that. That's chain rule. Okay, that's chain rule. So what is dy du? Dy du will give you 1 over u. Right? That will give you 1 over u. Because the same as you have an x there, so it's 1 on u. What's du dx? Du dx is actually g dash x. You derive the right hand side. Du dx will be derive the right hand side, so it's g dash x. You derive that, so it's g dash x. Okay, it's g dash x. Then dy du will equals to 1 on u times du dx, which is g dash x. So what is u? U equals to gx. So that is g dash x over gx. I have proved that. Okay, if you have log e gx, then the dy dx needs to be g dash x over gx. And that's how you prove it. I'm not going to prove the rest. You can use the similar idea to prove all of this. Prove the exponential, sine, cosine, and tangent. Okay, you can use the idea to prove all of that. Look at example 2. I will do some of this with you together, and I will require you to do some of that by yourself. Okay, so I want to derive the following. Okay, I want to derive the following. It's a pure calculation question. It's more like a part 1 exam question, and it's easier than part 1 exam. Okay, the level I give you here. Some of them are easier, some of them are a little bit harder. So let's look at the first one. You need to recognize what rule I need to use. Which rule I need to use for the first one? The first one, first log. Okay, exponential, not log. Exponential rule. So the rule is, if you have y equals to e to the power of gx, then dy dx will equals to g dash x times e to the power of gx. You just need to remember, when you have e to the power of something, you will always have that again in your derivative. Okay, you always have that again in your derivative. So in this question, what is gx? What is gx? Okay, we have x squared minus 4x plus 1. Okay, then fx equals to e to the power of gx. Then f dash x will equals to g dash x e to the power of gx. So what is g dash x? G dash x is 2x minus 4. And in the bracket, because it's together, times e to the power of gx. Gx is x squared minus 4x plus 1. Okay, so that is your f dash x. Okay, you derive the thing on the power, and you repeat, you like just copy that exponential function again. Any questions so far? It's just like pure formula. Okay, just need to remember. Okay, for part B, what I can do for part B? What I can do for part B? Can I directly derive it? Because I have times and divisions, I can't directly derive it, because you can't times the derivative together. You can only add or subtract. When you see something like that, I know some of you may learn quotient rule or product rule already, but try to avoid using quotient rule. It's like too long and it's too difficult. Okay, you can make mistakes so easily. So I would recommend you, if you can simplify them and make them all into the plus or subtract for in between terms, to do that. So my fx will equals to, okay, you will expand it first. Okay, expand this. So e to the power of x times e to the power of 2x, that will give you e to the power of 3x plus 3e to the power of x. Okay, expand that first. So what I will do later, I'll do e to the power of 3x over e to the power of x to the power of squared plus 3e to the power of x over e to the power of x squared. Okay, separate them and divide them individually. Then that will give you, okay, because you divide them, you will subtract the power. Okay, you subtract the power. And now, like, it looks perfect. We don't have any multiplications between the rules. So I will work out f dash x. Okay, the first f dash x, I have on the power, I need to derive this power. Okay, I need to derive this power. This power will give me 3 minus 2x. Okay, that's the derivative of the power. And because it's an exponential function, I will have whatever I have before again. Okay, just repeat that again. Plus 3 times what? Okay, 3 times, that's 1 minus 2x. Okay, you derive that, that become 1 minus 2x. Times e to the power of that. Okay, e to the power of that. So you can't leave your answer like that. Okay, you can leave your answer like that. Unless the question says you must simplify or you must make it into a particular version. Otherwise, that's the correct answer. Okay, that's the correct answer. It can take you very long to remember all of these rules. I find last year I have students who's really struggling to remember all those rules, so you need to do a lot of practice. I can't help you unless you're doing a lot of practice. Okay, this is rule is here. You don't need to understand, you don't need to know how it comes from. So you just remember that and can apply that to questions. So I put some harder questions here. You need to practice on them. Okay, that's the second one. Let's look at the third one. So what you can do first? What do you do at the beginning? You can't directly start derive that. So you rearrange the equation. Can you see the square root? We never do things with square root. Okay, we never do things with square root. So what you can do to the square root? What is the power? Half. Okay, we never write square root. We never derive square root because the square root is to the power of a half. So you can put anything into the power form, you put that into the power form. And then I can derive it from there. So which rule I need to use to derive this? Yep, chain rule. Okay, some of you realize that's chain rule. So because we have something to the power of a half, we need to use chain rule. Let's say we name this as gx. So gx equals 2e to the power of 2x minus x. So I know I need to derive that. Let's derive that directly. So what is g dash x? G dash x will be derive the thing on the log 2x, derive 2x, you have 2. And then e to the power of 2x minus x will be minus 1. So what is f dash x? For the chain rule, I need to put the power down. So the power is a half. I need to time g dash x. G dash x is a half of that minus that. And I will reduce the power by 1 but not changing the base. Okay, the base is that the power is half, reduce the power by 1, I'll have negative a half. So what I have here on the top is e to the power of 2x minus a half over, okay, over square root of e to the power of 2x minus x. Okay, the negative is 1 on that and the half is square root. And I have fraction over fraction, which is not very good. I can times 2 on both top and bottom. You get 2e to x minus 1 over 2 lots of square root e to the power of 2x minus x. Yep. Wait, which one? Yep. Okay, say louder. Yeah, g dash x. Yeah. This one? Okay, g dash x is 2. And then I will have e to the power of x. I'm not going to subtract the power by 1. Because it's not polynomials. That's exponential. Do you remember at the very beginning I said exponential and polynomials are different? One is base of x and to a number power, and the number power needs to be reduced by 1. And if you have exponentials, that is exponentials, you have power contained with variables, and you're not going to take 1 for that power. That is a power, but this is a variable power. It's not like a number. It's only when you got a number power and you reduce that power by 1, not everything. Okay? So x to the power of n, which is 1 time. And then e to the power of some x is another type. There are like 2 distinct types, and you need to really not confuse this. Okay? Okay, so let's see. Let's look at D. Okay, so we have separate part. Okay, I have separate part. I have first 3 square root x. So let's write y equals to 3 square root x. So 3 square root x is x to the power of a half. Then what is the derivative of that? Dy dx equals to 3 over 2 times x to the power of negative a half. Okay, times, this time is times the power to the front, and I'll reduce the power by 1. Because it's a number, it's a constant power, I'll reduce this by 1. So I have negative a half. Okay, the next one, y equals to e to the power of square root x. Okay, square root x. So it's x to the power of a half. This is your gx. Okay, that whole thing is on the power. Okay, the whole thing is on the power. X to the power of a half. So what is the derivative for that? What's the derivative for x to the power of a half? Is a half x to the power of negative a half is the derivative for this box. Okay, and then you times whatever you have before, which is e to the power of square root x. Okay, you derive the power. The power is x to the power of a half. If you derive x to the power of a half, you get a half times x to the power of negative a half. And then you have exponential again. Okay, I have the exponential again. Okay, let's have a look that y equals to 7 cosine 2 minus 3x. What's the derivative for that? Okay, first you have the 7 here, doesn't matter, just still keep the 7 here. But cosine will become what? Sine? Negative sine. Okay, cosine become negative sine. So you have negative 7. Okay, and then you would derive the things inside. Okay, you derive that inside. So what do you have? It's negative 3. Okay, you times negative 3. You derive the things inside, you have negative 3. And cosine will become negative sine. You already have the negative in front. So that's 2 minus 3x. That gives you 21 sine 2 minus 3x. And let's put everything back together. So we will have f dash x equals to Okay, so first derivative is this. So it's 3 over 2 root x plus a half root x times e to the power of root x, and minus the derivative of 21 sine 2 minus 3x. Okay, we have that. Actually, I can like just for fun, okay, simplify this a little bit. I can take 1 over 2 root x as a common factor, and I left 3 for the first term plus e to the power of root x, it's the second term, and minus 21 sine 2 minus 3x. Not necessary, you can leave the answer in the first line, but I just want you to see what is the you can factorize, okay, what is the common factor. Yep. Because that's a plus, that like I derived 7 that the minus and the minus have been cancelled, and you still have a minus in the front. So I derived that. Okay, I derived that. The minus sign remain in the front, and I derived the 7 cosine, and I work out that equals to 21 sine. And it's still a minus sign in the front. So it's still minus. You have 3 minus signs, so still a minus. Okay, part E will be quite interesting. Tell me which rule you will use to derive this. Which rule you will use? Exponential, logarithm, sine, cosine, tangent, which one you will use? Like why, like tell me what is the problem why you can't answer this question? What's wrong? What's wrong to make you feel like you can't do a derivative, derive that? Have a guess. Have a guess. What's wrong? What's wrong here? Why you can't derive? We can all derive the previous 4 questions easily. Or if you think you can't derive, can you tell me what's the derivative? What I just said, for exponential and logarithm, you can only derive when something natural base. Okay, go back. You must have base E for both exponential and logarithm. That's as I said at the very beginning. You can only derive things when it's a natural base, because I just talk about e to the power of something. I never talk about 3 to the power of something. So now the problem is I don't have the natural base. The 3 is not the natural base. So what I will do is I want to make it to a natural base. Okay, I want to make it to a natural base. Write down, I don't think you may know this, so please write this down. That's something from logarithm, okay? A to the power of log ax, that will equals to x. Okay, a to the power of log ax, that will equivalent to x. Okay, so what that means? So I want base e, right? I want base e. Let's make x to be 3. So it's this number here. Okay. I want to see what 3 equals to. Okay, I want to see what 3 equals to. 3 will equals to, let's make a to become e because I want base e. So that will be log e 3. Okay, 3 is what? 3 is e to the power of log e3. Okay, I can change 3 to log e to the power of log e3. So what that can simplify this. So 3 is what? 3 is e to the power of log e3. Okay, so you still have the 3 here. And then the whole thing will to the power of 4x. Okay, the whole thing will to the power of 4x. Okay. Then let's write another rule here. A to the power of m, then to the power of n will equals to a to the power of m times n. Right? A to the power of m and then to the power of n will equals to n, a to the power of m times n. So what fx can be simplified to? That will be e to the power of 4 times log e3 times x. Okay, times those two numbers together, so it's 4 log e3 times x. What is 4 log e3? You don't need to know how large is that. What you just need to know is that's a constant. Okay, that's a constant. That's a number. That's like 1, like 2, like 4. Okay, it's a constant. It's just a long constant. So you have a constant times x on the power. And can you see that's e to the power of ax? Okay, like a constant times x. E to the power of something times x. Then what is f dash x? F dash x will be derive the top. Okay, that's a linear. Okay, a times x. So derive the top. So the top is 4 log e3. Okay, that's whatever you have on the a, the constant. So that's the constant. And then you will repeat again what you have for log. So e4 log e3 times x. And remember that is 3 to the power of 4x. Okay, that is 3 to the power of 4x. Okay? This is that. And going back is 3 to the power of 4x. That will be equivalent. Okay, just make that into this form and then finally you need to simplify it down. Okay, simplify it. Okay, that's how you derive an exponential function without a natural base. Okay, without a natural base. That's how to deal with this type of questions. Okay, try part F by yourself. I'll give you 2 minutes, 3 minutes then. Okay, do it really quick. It will be the same as the previous question. Okay, most of you could figure this out, so I'll just quickly go through it. So 4, wait, I think I've got some problem here. Okay, 4/3 should equals to base e log e 4/3. Fx should be e to the power of log e 4/3, then to a power of 2x. Then fx will equals to e to the power of 2 log e 4/3 times x. Okay, it's another constant times x. So f dash x will equals to derive this on the top, which is 2 log e 4/3. And then repeat this whole thing again. And this whole thing equals to 4/3 to the power of 2x. Okay, 4/3 to the power of 2x. Any questions for this part? So that's with not base is not natural numbers, and how you can derive this exponential. Okay, change it to natural numbers and then derive it. Okay, I'll do 1 log and then I'll do 1 tangent. Okay, I'll do another 2 here, and I'll ask you to finish the rest of that before Wednesday. Okay, before Wednesday. I'll go through the rest on Wednesday. Let's have a look at this one. Let's have a look at this one. We have gx equals to log e. Okay, so that's 8x minus 15 to the power of a half. Every time when I see square root, I will change it to the power of a half. And that equals to a half. So we have this whole thing inside. Okay, I need to derive the whole thing inside. So what's the derivative for log? If y equals to log e gx, then the derivative dy dx will equals to g dash x over gx. Okay, you need to derive the things inside. So let's say we have y equals to 8x minus 15, then to the power of a half. That I need to use chain rule to derive that. Okay, dy dx equals to, okay, derive that, drag the power down, which is a half. Derive what you have inside, which is 8. Reduce the power by 1, which is negative a half. And that gives you 4 on square root of 8x minus 15. Okay, so what is g dash x? G dash x will be the derivative for the in the bracket over whatever you have in the bracket. And how I can simplify this? I can times this by the denominator, which is 8x minus 15, and I can times square root 8x minus 15, and that gives you 4 over 8x minus 15. That's a really simple version, 4 over 8x minus 15, because root 8x minus 15 times 8 root x minus 15 equals to 8x minus 15. And then the numerator is just 4. Okay, so it's 4 over that. I have done 1 log with you. I will need you to try the rest of that. Can see give you a hint here. Can see this 4 here. This 4 is not base. E is not a natural base, so you need to use change of base formula. Okay, change of base formula. So what is change of base? Log AB will equals to log CB over log CA. Okay, you can change it to any base. The C can be any number. Therefore, the C can be natural number. Okay, the C can be natural number E. I can change it to any number. I'll ask you to think about this first, and then I'll go through this with you. So just be aware this base is not E, so you cannot do directly as what we have done so far. Okay, I'll go through the last one. JKL, I'll go through L with you. So for L, hx equals to root 3 times 3 tangent 3x plus 1. So it's pretty easy to do this one. So what tangent will become? What tangent will become after you derive that? Second squared. Okay, second squared. So the constant will still be there, and you derive the things in the bracket. 3x plus 1, you derive that, you have 3 times tangent will become secant squared, and you will have whatever you have in the bracket before. And h dash x will give you root 3 secant squared 3x plus 1. Okay, for this px, I will recommend you to write this into this form. It's sine 2x plus 1 to the power of -3. Okay, that's to the power of -3. And then use chain rule to derive that. For this px, I will recommend you to write 3 cosine 2x minus 1, then to the power of a half. Okay, then to the power of a half, and then derive from there. For question K, okay, this 8, not K, for this I, what you do is, I'll put this into log e x squared minus 4x plus 1, because that's the b, log cb over log c of 4. So what is log e4? Log e4 is a constant. I can write that as 1 over log e4 times log e x squared minus 4x plus 1. And you can derive that. Okay, you can derive that. I have changed of the base. Okay, change the base to the natural number. So before Wednesday lesson, could you please just finish this page? Okay, all the thing before this page, and I'll go through the answer with you on Wednesday.